Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our doctor. So I, Muhammad Ziyaafser bin Muhammad Zina, Kagineswaran and Vinodh from Group 9, would like to present our OS project, in which our topic is fixed and dynamic management, next fit and worst fit. So the real life scenario, the real world scenario that we chose in this group, in this project that is related to that topic is cinema ticket booking system. So we will actually explain more about it in the following animation video. By the way, we chose animation as our OS project execution. So before proceeding to the video, we would like to talk about our group collaboration, our contribution. So we three of us tried our best to make the equal and fair enough. So first, I would like to talk about my contribution. So first, I actually find and discuss the project aim, requirement, objectives and target. And then moving on, I actually handled the report writings and documentations. And third, I did find informations about next fit and worst fit. Fourth, I gathered information and key functionalities needed for the project. And then I review and finalize the project presentation. And then I also did some brainstorming ideas for the algorithms. So moving on, Kagi would talk about his contribution.
Alright, hi, my name is Kagineswaran. So what I contributed was, firstly, I did the task for teammates. Next, I was in charge in finding information about next fit and worst fit. Third, I was finding and getting ideas of real-world application related to the topic. The fourth, I was in charge of designing the animation video. Fifth, I helped brainstorm ideas for the algorithm and real-life application. And finally, I reviewed and ensured the report aligns with the project. Next, Vinodh will be talking about his contribution.
Okay, so hi, my name is Vinodh, and about my contribution, first I make a survey on which animation platform to be used, and then I find ideas on the real-world application related to the topic, and then I also create and design the animation video. And following is ensuring the video, the duration with the time is limit, and last is brainstorming idea for the animation video. So this is all our contribution, and now we will go to the animation video.
Okay, so this is our project, Fixed and Dynamic Memory Management, Next Fit and Worst Fit. Now I'll be talking about real world application with the cinema ticket booking system. As you can see in this scenario, the system aims to efficiently allocate seats to customers based on their preference while maximizing the utilization of available seating capacity. The cinema ticket booking application would have the following functionalities: implementing next fit and worst fit for seat allocation and seat selection respectively. The cinema ticket booking system can efficiently allocate seats to customers while considering their preferences and optimizing seat occupancy. It ensures a better user experience and maximizes the utilization of available seat capacity within the cinema hall. Next fit. So for our next fit, I'm going to talk about a modified variant of first fit is the next fit. The search starts at the last hole allocated. Basically, that is what next fit is. So as you can see, there are a few advantages of next fit. The first advantage is next fit is a considerably fast searching algorithm, as it is comparatively faster than first fit and best fit allocation. By providing larger gaps between allocated partitions that can be utilized for future allocations, the next fit method aids to reduce memory fragmentation. This lessens the amount of small gaps and assists in giving tasks bigger continuous blocks of memory. Next fit example, a cinema ticket booking system. So as you can see, this is where the next fit is utilized, seat allocation. The next fit algorithm aims to allocate seats sequentially based on the customer preferences. Here's how it can be implemented for seat allocation. The cinema hall's seating arrangement is represented as a data structure, such as an array or partitions. As customer requests a certain number of seats, the algorithm iterates over the seating arrangement starting from the last allocated seat.
Next, seat allocation. So this is the demonstration of how it works. It searches for the next available group of seats that can accommodate the requested number of seats. This can be achieved by iterating through the seating arrangement and checking for consecutive seats showing status of seats. Example, vacant, reserved, or sold. Once a suitable group of seats is found, the algorithm marks those seats as reserved and allocated for the customer. The status of those seats is updated in the seating arrangement data structure. The algorithm remembers the index or position of the last allocated seat for the next allocation request, ensuring that the next feed process continues from the point onward. This process repeats from subsequent allocation requests, ensuring seats are allocated sequentially while considering customer preferences. Now, worst fit. So, worst fit allocates the largest whole. It searches entire list and produces the largest leftover whole. And what are the advantages of worst fit? There will be considerably internal fragmentation since this procedure selects the largest whole or partition. This internal fragmentation will now be sufficiently large to allow for the placement of additional small processes in the underused partition. The disadvantage, the lengthy procedure of perusing every memory partition before choosing the largest one among them results in the lengthy process being inefficient and time-consuming. Now, worst fit example, cinema ticket booking system.
So, seat selection is one of the worst fit algorithm. The worst fit algorithm aims to find a group of seats that has the maximum number of available adjacent seats and satisfy the customer's preference. Here's how it can be implemented for seat selection. So when a customer select their desired number of seats and location preference, example the front row or middle row or back row, the worst fit algorithm is employed to find the group of seats that best matches their preference. The algorithm iterates over the seating arrangement, checking for groups of adjacent empty seats that can accommodate the request number of seats. So here is an example on how the animation of how seat selection works. So first, it will keep track of the group with the largest available number of adjacent seats that meets the customer's location preference. Once the group of seats with the maximum availability adjacent seats is found, the algorithm marks those seats as reserved or allocated for the customer, as their status is updated in the seating arrangement data structure. So that's for the animation part.
So to conclude our project, so far we can see next fit and worst fit can be implemented in many systems. The one we chose was seat allocation and seat selection. So I think there are many other systems that can benefit by implementing it as well. That is all for our group. Thank you very much.